Welcome to the SwayamPrabha series in computer science. In the series, this is a course on artificial intelligence, and we are in last 3 sessions, which will be the practical implementation of generative AI. Last session we saw the prompt types in addition to prompt components. So this session what we will do is we will try to program by ourselves using an LLM model, but before that we will just look at a few parameters that we have seen last time. So if you look at the parameters, we talked about the temperature. The temperature, it controls the creativity, like suppose you have the code, then the creativity should be very less. So we will make it as temperature close towards 0. So an example for coding assistant, if we are developing our own assistant using codes, then the temperature that to be given is 0.1, and top P is the possibilities for the response to be given. If it is 0.9, it would give all possible responses, and the maximum tokens is 400 for coding assistants. Whereas if you take the other case, the creative story here, the temperature is to be 1. The reason is we want it to be more creative. So temperature here should be close towards 1, and top P again it is 1. Why? Because we want to give variations, different variations, and all possible variations will be generated. And in this case the maximum tokens is 1000 in contrast with 400. The reason is we need a 1000-word story. So these are general parameters that are to be considered while we code. Now we will move into the actual code, but before getting into code, I want to give you an introduction of where to get the API key, because in order to code using LLM we need to generate a key, and suppose if it is OpenAI or Gemini or OpenRouter, I have given 3 examples where we can get a key, and the similar formats exist in other LLMs also. Say if you take OpenAI, and these are important for the subscription based. So, and whatever I have given now is for the free tier. Let us take an example of this is an example of OpenAI. This is for OpenAI where we have the API keys. Yeah, sorry. And if you just look at the OpenAI models, we have GPT 5.5, 5.4 and 5.4 mini, and if you look at the way that is mentioned in the last session, we talked about the cost along with the way it represents the context window or context length, it represents along with the largest number of tokens. So if in 5.5 it is $5 per 1 million tokens, and 5.4 it is slightly less, and 5.4 mini it is less. So if the latest models, it is more costly, and if you look at the way it is being done, we can use it for coding, customer support, some recommendations. So there are plenty of use cases that can be designed using this model. Now to get the API key, this is the website with which we can get. So all that we have to do is create a new secret key, and it will generate a hexadecimal key that should be saved as a secret within your portal. You can save it using your textpad or a notepad, but you have to keep it a secret. This is for OpenAI. The other would be for Colab, and that we can use this Google AI Studio. Once we click Google's AI Studio and log into it, here I have logged into my account, and here I have already generated one key which is right here, and it is actually closed, and it's since it is a secret key hexadecimal, it should not be visible. So here using this create API key, at this portion we can use this in order to generate the key, and using that key again that has to be saved separately, and we can generate multiple keys also, but after a specific portion of it, it will ask for upgrading it, or we have to pay that amount in order to sustain the LLM. So this is for the second one, which is Gemini. The third LLM is the Open Router. Open Router is I feel much better because it is one API key for different models. So if you look at Open Router, there are multiple models that are there. So if you will just go into here, see the number of models. The models include both free tier as well as the paid ones. So we can pick any model here according to the need that is based upon us. So it can either be text based or image based or video based. We can use those models with one API key, whereas in OpenAI or Gemini we have to have separate keys for Gemini, just separate for OpenAI. Here with one key API key, multiple models, whether it is Claude or Gemini or Qwen, any model can be accessed. So what I have done here is we generated an API key using Open Router. So here if I give the open email address, we would get the API key from Open Router. So that key I have saved it, and why it is needed, it is used for the coding purposes, which I am going to demonstrate now in this session. So assuming that we have the Open Router key, then we can start our coding exercises. So the coding exercise is exactly the same what we discussed in the previous session with the different components and the types of prompts. So if you see, this is the Google Colab, the portion of it where we have written the code, and the first portion is setting up the model. Again, the goal for our exercises, can we design a prompt using our code and generate it. This is our use case, just demonstrating whatever we have done using the internet. Earlier we using ChatGPT, we just given the prompt and it responded. Now what we are doing is we are writing our own programs so that it responds to our queries as per our design. So first, whatever the API code that was generated, we are taking it, and here if you see on the left side, this is a Google Colab. At this portion, this is the key, this is called as secrets. So if I click that, I have two keys here, one is Gemini and one is Open Router. So the key that I got from Open Router, I have saved it here. So at this portion. Now using this key, I am going to talk to Open Routers through API key. From the Open Routers, I am going to connect it to a model there. So that part of the code is the first cell. So I will go through step by step how to set up the model, and in this case I have used Open Router. It for your case, it can either be any of it like Gemini or OpenAI or Qwen or anything else. So if you check this file, the first three lines, Google Colab import user data, this user data is given for getting the secrets from API key, and then import request, that also from regarding the key, and it has to go through HTTP and go into the model. So that's why we are giving, and import JSON. JSON is the format, sometimes it is needed. And this is the line where we are specifying the Open Router key. So user data, the user data is from here, we get the Open Router API key. This key is got from the secret, this portion. So this is the connection line that gets the Open Router API key, and suppose these two lines specify if there is no Open Router key, then we are raising that as an error, this line. And assuming that we have the Open Router key, and the model I am using is Neo-Motron 3 Ultra. This is actually a free tier given by NVIDIA. This is available in Open Router. So here in the different models that are given here, the free tier which I have used would be NVIDIA under Neo-Motron. Why? Because for this exercise I thought this should be sufficient enough, and it is a free tier. So I have opted for it. And the API URL is openrouter.ai. This is the router. So these two lines are needed. So what would happen is when we give a query, it would go into this open router, get the authentication through the API key and go into this model in order to process our data. Now this is the query format that we are giving. This is the function, Python function that we are designing for defining the query with the prompt. Prompt is the what the user is giving. In our case, we will be giving the prompt and that will be carried over here. And we are setting the temperature to 0.7. 0.7 is, as we have seen, the parameters. If it is towards 1, it is more creative, and maximum tokens right now we are maintaining by default it is going to be 200. We are specifying these parameters here. And the authorization, it is through the open router API key which we have designed it here. We have given at this line. And the content type application, it can either be from the JSON type. So in this function, it describes the structure of the model. The model is this model that we have defined it here, and the messages, it can be in the form of role, user, content. Content would be role as user, and the content would be the prompt that we are giving here. So this is a Python dictionary where the user goes to role and prompt assigned towards the content. And the temperature is 0.7 here, and the maximum tokens we are giving as 200. This is the default, but suppose if we give 5000 inside our prompt itself, it will go and sit as 500. Now given this function, the response that we get is request.post. This request is the one that we have defined here, import requests. Request.post, through ARL we design the headers and we get the headers and the input as JSON. And suppose if it is not 200, if it is this is for the error, suppose there is error, this will be raised, otherwise we would get back the result in this form. So this is an example here that we are saying query hello that. So suppose this is the input that we give. So what happens is this query would go into this portion, and the prompt that we are giving is hello there. This goes as a prompt here with temperature as 0.7 and maximum token 200. And once this function is executed, we are getting the result as hello, how can I help you today. So this portion is about setting up the model. So any model that we use, suppose this is the first step that we have to design. First we have to import the necessary libraries, get the API key and get the model whichever is comfortable, and based on the model design how the query would be, the data format of it, and how the response should be. So those things we are designing, we are writing the code at this step. So the whole step is called as designing the model for our entire assistant or the AI assistant or AI prompt structure. Now that we have set the model, this is the prerequisite. Now we have done it. Now we will go through step by step different types of components of prompt and types of prompt. And with this model, suppose I ask how does a computer work, then print query prompt. So this is the prompt that is given here. This prompt will go into again this function query of prompt, and the result here would be I'll score a computer, and you can see that I am not reading the full thing, but you can check it yourself using some other model or anything of your choice. So this is just an example of setting up a model and giving back the result. The next one is giving a prompt with more tokens. See, earlier I said this is the tokens, maximum tokens we are giving as 200. Suppose we want a bigger context flow, which is suppose instead of 200 I need more explanation, then I am fixing the maximum tokens to be 500 here. So the same type of prompt that we are giving, prompt is explain the working of a computer to first year undergrad students, and suppose we take this prompt and pass that to a function of query, and remember this query is the function that we have written here, this function. So, it will go into this function, and the result that we get back here is, you can see how big this response is compared to the one, this is the earlier one with 200 tokens, and this is the response given by the model with 500 tokens. See, this component is the, if you remember the first one, it is the directive. The second component, we are attaching a role to the prompt. So, the prompt here is explain overfitting using an example. This is the default model style, this is the default directive style. Now, we are including a role to the prompt. We are saying you are a CS professor teaching undergraduate. So, we are asking the LLM to be a CS professor, and using that tone, can it explain overfitting in supervised learning with one intuitive example, and it should be very clear and structured. So, this is the prompt we are giving in, and we can see the difference with this prompt and the second prompt. So, the default model style, it gives the overfitting and the result with the analogy. So, the analogy that the first specified a student who memorized the practice test. Now, with the role prompt, the same prompt, if we attach the role, then it says overfitting when your model memorizes. So, you can see the difference, and it gives the example here. Student who memorized the practice exam, the setup, the two students model, where this case the two students model for that prompt is not available in the first default style. So, you can see the difference between directive and the role. Now, what would happen if we have the same prompt with different temperature settings? So, this is the same prompt, give three different analogies that explain overfitting. So, the prompt that I gave is very much needed in the machine learning side for undergrad students. So, suppose if we give this prompt and we are having different temperatures like 0, 0.3, 0.7, 1, and if you see the temperature and having a simple for loop, if we are passing up the prompt with all the temperature, we see that in temperature 0, you can see the difference. There are three different analogies. It says rote memorization, the scenario, the twist, and with 0.3 we can see the difference, and 0.7 you can see the difference with one other type of overfitting which highlighting a different facet, and it would give a slightly different connotation which would be more creative. So, using the structure of the three different temperature settings, we could see how different our prompt would the response would be. So, based on our use case, we can define the temperature. So, that is the essence with which we are doing it here. Now, the another example with prompt is with, can we have the examples within prompt, like we saw in the components. The fourth component is prompt with examples. So, this is the prompt that we are giving. You are teaching first year CS students. We are giving two examples of patterns. This is the pattern. The question is, what is overfitting? We are giving the answer. And what is regularization? Regularization is, we are giving the answer. Now, we are asking LLM to follow the same pattern and the response for cross validation. So, we are asking what is cross validation, and LLM should respond similar to the answers that is given here. So, we are passing it to prompt, and here if you see the temperature I have given is 0.3, whereas earlier in this case the first one I have given it is 0.7. In this case we have given as 0.7, okay, because it has to follow the same structure. We are giving as 0.3 here with the maximum tokens 200. So, for this type of prompt, the answer the LLM gave is cross validation is like rotating study groups before the final exam. You split your notes into K piles, study on K minus 1 piles and test yourself on the leftover pile until every pile being the test. So, this goes on. So, this is the output for that portion of the prompt. The next example that we give is the chain of thought prompting. Say this is an example for it. You are a careful reasoning assistant. Explain step by step why the following classifier is overfitting. It achieves 99% on the training or if 60% on the held out test. The model has millions of parameters and data set has only 1000 examples. So, we are giving the details of how the training and test out set, and we are asking the LLM to find out the reason based on these data. So, and how the format should be available also given here. So, first we are asking the LLM to list the facts, then reason out, finally give a short conclusion. So, this is a classic example of chain of thought to reason step by step. And while doing it here, you can see that the temperature we are giving is 0.2 because it has to be very realistic, it should not hallucinate. So, we are giving 0.2 and maximum tokens is 400. So, based on these conditions, this is the response that the LLM is giving. So, training accuracy is 99%, which we gave exactly, very high, which is near perfect. So, if it is close to 100, it is perfect. In the held out test, in the testing set, suppose it is 60%, then it is having training is more and testing less, there is some gap within this, there is some error. So, this is the details that LLM is reasoning it out. So, this is the step by step reasoning, say there might be overfitting or generalization. And the next example is explaining the concept to first year computer science students. Say this is a prompt that we are giving, explain the concept of, this is a concept, and this concept whatever in curly brackets, it is actually a type of function that we can pass into. Concept to a audience student in a style way using utmost words and one example, and if you give that, the concept we can define separately, audience we can define separately, and the query with prompt is given, the prompt again the user can feed inside the prompt. So, this is the actually the function that is being written with the temperature of 40% and maximum tokens, whatever the words that we are mentioned here plus a few more, so that it does not break, the words does not break in the middle. So, this is an example of explaining the concept which is a part of the prompting techniques. So, given this, then we are getting the result like this from the LLM, from the designed LLM. So, we need to explain the concept, theorem and so on. So, these are some of the practical examples I thought it would be useful for you to get started with working out generative AI. Now, having all these into effect, now we will get into the portion of it where we would start with prompting, and we will get into the next topic as agent. And agent in your syllabus, actually it is in first unit we started with what is an agent and the intelligent agent. And the intelligent agent here would be, say the agent has, suppose if you remember the diagram, you have the agent and the environment. This is the environment and the agent. Agent gets information from the environment and acts according to it. So, if you take, and there are several types of agent that we did previously, like simple agent, goal oriented agent and tool based agent or state based agent which has memories, and utility agent we have already started some definitions about agent in unit 1 when we started. In the next session, we will be going through in detail and we will also attach prompt to it. Okay. So, in the next session, we will do on agents. Thank you.